Thanks, John. This is Hans Blashek, and I'm really happy to talk to you today about our brand new facility on the campus of the University of Illinois, the Integrated Bioprocessing Research Lab, the picture of which you see in front of you now, which is an artist rendering of the facility. The project or the construction is underway at this moment, and of course, we're very excited about it. The facility was really designed to be a connector between bench scale work and commercialization. And you'll notice that the location of the facility, the IBRL, is situated near the south end of campus, where a lot of ag engineering types of activities take place and where a lot of faculty are co-located, in addition to being near our greenhouses, which of course would supply a lot of the potential feedstock that would be tested in this facility. So today I just wanted to tell you briefly about this facility. Again, it's designed to be focused on addressing the need that occurs between benchtop research and proof of concept. And essentially what I want to do in the agenda is to cover the history, the mission of the facility, the types of projects that we envision, the types of bioproducts that can be produced, and tell you also a little bit about our educational component, which consists of the Illinois BioEnergy PSM program, which has been in existence for a few years now. So the history is that, believe it or not, this building has been underway since about the year 2000, where we started the planning with funding from the state of Illinois. It's a $25 million building. We finally, after that long duration of time, had a celebration of construction in October 2014, groundbreaking December of last year, and we anticipate that the building will be completed. It is on schedule. We anticipate a spring 2016 building completion, and of course we're very excited about that. The mission of the IBRL is that it was designed to advance research, education, focused on, in a broad way, on renewable fuel, food, and fiber-based processing platforms. And of course, because there is funding from the state of Illinois, there was an understanding that this facility would help to stimulate bioeconomic development in the state through the transitional scale-up of developed technologies, ultimately leading to commercialization. Now, we've described the IBRL as a hybrid facility, and the reason for that is it's a little bit different than many of the buildings on campus in that it will bring together, it's designed to bring together, multidisciplinary teams, which include faculty as well as our industry partners, focused on particular problems in the entire value chain. And of course, one area would be looking at plant genetics, microbial genetics, and how that ultimately will impact the bioprocessing of the materials that are produced. Unique attributes, as I've tried to suggest, is that this is a very flexible facility. It's designed to be plug and play. It has an analytical laboratory associated with it, and so it really has all the components we feel that are necessary to move from basic research discoveries to commercial products, and essentially allow us or enable us the ability to generate value-added products using renewable bioprocessing operations. So really, the focus then is that the IBRL was designed specifically to fill this gap in the channel from innovative research to market application. Another way of thinking about this is that it fulfills in some way the fourth leg of the mission of the university, which is a driver toward commercialization and economic value and impact. Many of the feedstocks, as I suggested, that will be tested in the IBRL, and we'll give some examples of what those might be, various types of energy grasses and other materials from agriculture in order to look at sustainable production of various types of bioproducts that can supplant petroleum-based products. So both in terms of crop redesign and also in terms of microbial, um, the generation of new microbes which have potential for producing next generation fuels and chemicals is certainly part of the strategy. This is a cross-sectional view of the IBRL, and it gives you some sense of the high bay region where we will have an opportunity for both industry folks as well as faculty to carry out their innovative research and development activities. This is a rather unique feature of the IBRL, the utility bays, where we actually have movable walls that can be used in those cases where industry partners have intellectual property issues with their particular product and development. And the unique feature, of course, is that we can provide this space to them. We can also provide many of the utilities that they will require in that particular space. Just to give you some sense now of the value chain and our ability to address various aspects of the value chain in moving from various types of products. We have different types and pieces of equipment that we already have in-house, and some that will be arriving as the building gets closer to completion. So we can do grinding, we can do biomass deconstruction and pretreatment of various types that ultimately will allow us via a sugar platform to produce various types of bio-based products. These could be liquid fuels or they could be chemicals of various types. This gives you some idea of our fermentation capability. We will be able to move through various levels and scales all the way up to 300 liters, which our research has shown is a nice scale to be able to move through to commercialization by our industry partners. In terms of projects, we currently have two projects, one with the Illinois Department of Transportation, which brings together teams of faculty focused on agronomics, microbiology, strain development, processing engineering, as well as policy issues. And in this case, we're actually looking at the feasibility of planting energy crops along Illinois highway right-of-ways and trying to do this in a sustainable and long-term way. The other project is funded by the Department of Energy, and here we have very fundamental work going on with strain development for the production of next generation liquid fuels. So in addition to these energy grasses and food-related co-products, examples of sustainable bioenergy crops have recently been developed and examined here at the University of Illinois, which include tropical maize, which is a high biomass, high sugar corn hybrid that instead of producing an ear of corn actually accumulates sucrose in the stalk and produces negligible, grain, and also Lipid Gain, which is a sugar cane engineered to produce non-food oil as a drop-in liquid fuel. So with that, I'll let John ask a couple of questions, and then my colleague Vijay Singh will talk to you in a few moments.
Okay, hello everyone. My name is Vijay Singh, and Hans mentioned about the capabilities of IBRL. What I'm going to do is briefly talk about two examples of new bioenergy crops that we might use in IBRL and conduct scale-up studies. So the two new bioenergy crops that I'm going to talk about, one is tropical maize and the other one is Lipid Gain. So tropical maize, what is it? It is corn. Corn, like all other plants, is photoperiod sensitive, and hybrids that are adapted for tropics when planted in temperate environment exhibit changes associated with this photoperiod sensitivity, such as delayed shoot maturation, more vegetative leaves, and delayed flowering with disruptive coordination between pollen production and silk emergence, which greatly reduces kernel pollination and reduces grain yield. which is great because we grow tropical maize for its biomass, not for its grain yield. Here in the picture, you can see one of our faculty members, Dr. Laura Gentry. She's quite tall, but you can see the plants behind her, they grow as high as 14 feet. Now, tropical maize has three very important characteristics that make it a very strong candidate for biofuel crop. One, it produces a lot of biomass per acre. Two, it stores sugar in stock. And three, it requires about 50% less nitrogen compared to field corn. So here, the production of sugar in corn is not a new idea. Corn was domesticated about 10,000 years ago in El Salvador, and the most recent parent for corn is a grass called teosinte. Teosinte is a very ugly looking corn, has very few kernels, which are very hard, but teosinte does store sugars in stock. And it's believed that the ancient people grew teosinte for two reasons. One, they wanted to chew on the stalk. Two, they found that the juice fermented into an alcoholic beverage. Anyways, here's a very nice experiment that was done here at University of Illinois. In the picture, you can see in the front is field corn, and the back is tropical maize with almost no nitrogen application. And you can see the field corn does not do so well, but tropical maize grows very well. Now here is the picture of the U.S. industry, sweetener industry. Yellow is where we grow corn, green is where we grow beets, and red is where sugarcane is grown. Now we can't plant sugarcane up here in Midwest because the climate doesn't allow that, but we can plant tropical maize in Midwest using same agronomic practices as we use for corn. So here you can see tropical maize being squeezed out at our experimental farm, and the sugars that come out, the juice that comes out contains these sugars that can be easily fermented into ethanol. And these sugars are fructose, glucose, and sucrose. Here's just a rate of fermentation. You can see it's a very fast rate of fermentation. It completes very quickly. And even if we go to very high sugar concentrations, we are able to finish and we don't see any stuck fermentations. So it works very well, and all these sugars can be easily fermented. So in this case, we are not breaking starch down into glucose and fermenting glucose. In this case, we are directly getting the fermentable substrate, which can be fermented into ethanol. Tropical maize is also applicable for Brazil. In Brazil, mostly it's sugarcane that's used for ethanol production, but ethanol production from sugarcane in Brazil only operates 7 months in a year. The 5 months is what's called the inter-harvest season, where the plants will shut down because of not availability of the biomass, and they go into maintenance mode and all that. We believe tropical maize can come in during the inter-harvest season and can be converted into ethanol, and the biomass that's produced can be used for producing electricity. Okay, switching gears, I'm going to talk about the second bioenergy crop. Well, before I finish, here is a picture of Dr. Fred Bilo, who's the faculty member leading the tropical maize development effort here at University of Illinois, and his former graduate student, Mike Vincent. And you can see that Dr. Bilo is holding a tropical maize corn plant, and Mike is holding the field corn. You can see the difference in the height, the amount of biomass that's produced with tropical maize. Okay, next project is Lipid Gain. In this one, we are transforming sugarcane to produce oil. Plants naturally produce oil, but currently, in the current states, it's used in their metabolism by upregulating the genes to make oil and downregulating the genes that consume the oil. We can teach the plants to store oil. Currently, we have Lipid Gain, or sugarcane that produces lipid with about 2% oil on dry basis, and goal is to achieve 20% oil in Lipid Gain. That means no sugar, all we get is oil. This is a ARPA-E funded project between University of Illinois Brookhaven National Lab, University of Florida, and University of Nebraska. Dr. Steve Long from University of Illinois leads this project. In addition to increasing the oil content, work is also being done trying to improve the photosynthesis by looking at the distribution of light on canopy, on crop canopy, and also improving the cold tolerance of lipid cane by crossing it with its cousin that grows in Canada, Miscanthus. So here is just an estimate of where this lipid cane can be grown in US. And what you see, the colored part of the map is where we have 23 million acres of land where this lipid cane can be planted. The dark green is where sugarcane currently grows in US, but by improving the cold tolerance, we can get more land where we can plant this lipid cane. And from this 23 million acres of land, we can get close to about 40 billion gallons of biofuel. So we conducted some techno-economic evaluation of lipid cane and compared it to corn, and corn for ethanol and beans for biodiesel production. One thing is, even at 2% level, which is where we are right now, we can produce more biodiesel per acre of land compared to beans. So here is just some simulation results, and it just shows that the price of producing biodiesel is much less in lipid cane, 20% lipid cane compared to beans. And as we start to increase more and more oil in lipid cane, we'll have less sugar to convert into ethanol. And also, even at 2% level, the ethanol that's produced is cheaper than ethanol that we get from corn. So in conclusions, sugarcane producing lipids, we have achieved about 2% oil in lipid cane. The goal is to take it to about 20% oil and over 50% improvement photosynthesis, and it has tremendous potential to produce very large amounts of biofuels in the US. I guess I will turn the presentation back to Hans, who's going to talk about some of the educational component that is related to IBRL and some details related to the construction of the facility. Hans?
Okay, thank you, Vijay. So I just wanted to conclude today's presentation by telling you a little bit about our BioEnergy Professional Science Master's Program. This is a program that was started in 2010 and is a 16-month program in which our students are essentially in a sort of a green MBA type format, if you will, are exposed to science courses, and specifically in specialty areas that are indicated on this slide, and also get an opportunity to have the associated business courses that go along with it. So it's a 16-month program. We're actually in the sixth cohort actually coming up. We typically have about 10 students per cohort, and we're excited that the new IBRL facility will actually provide the facilities and the opportunity for internships for these students, which is an important component of this program, together with having an opportunity to do workshops of various types. I just wanted to show those of you that are not on campus some of the photographs that show the construction activity that is ongoing right now. And again, you can see that this facility actually will surround an existing, much older, obviously, building that has been used in the past in bioprocessing related activities. This gives you some sense of the aerial view of the facility, which is at the lower portion of this particular slide, and it also gives you some sense of the overall size. The interesting thing, someone asked about how this facility differs from other facilities across the country, and what I can tell you is that given the rather long time needed to get this facility approved and funded and construction started, we have been able to take advantage of that time and modify it in such a way that I think this will be the most flexible of the facilities that are out there, certainly across the country, we've had an opportunity to visit some of the other facilities that are affiliated with various universities and or national labs. And we've been able to take that information and use it to have a facility that I think will be extremely flexible and also has the associated analytical capacity as part of its footprint, which it turns out not all of these other facilities have that capability. So I think that's one area that we've been able to work on that allows us to have a facility which is truly unique and will be usable. Well, the next steps are that we continue to offer conferences, and we'll have additional workshops going forward once the facility is completed. We now do have an advisory board that's made up of industry folks, academia, as well as the state of Illinois. We are looking potentially for additional partnerships, but we are working currently with an engagement with industry and in a broad sense, which will bring together a cooperative arrangement between industry and university faculty and capacity. So we're quite excited about this future opportunity, but we're also very much interested in making additional connections with industry folks. The cost of the facility is $25 million, and I see that someone has asked that question. Let me see if there are any other questions that I can answer here. Sorry. Well, someone asked about being focused on plant breeding and genetics versus yeast pathways. I think this facility, again, was designed to be extremely broad, so we're not necessarily married to a particular microbe, or the flexibility of the space will allow us to do certainly yeast work. Plant breeding is an area that is really a focus of the facility, because I envision that we'll have new crops and new plant materials that have been modified in some way that we will then test for their ability to be processed. I mean, I see that as a critical aspect of what this facility is all about. We're looking right now at specifically at an I-72 corridor. For those of you not familiar with the state of Illinois, that's a highway that crosses about midway between the state, and we're looking at a way to engage various companies in the central Illinois area. But again, we're open to other companies and other opportunities along those lines.
Hans, if you want, are you a presentation? I'll facilitate the question and answer session.
Sure.
Okay. If you'll mute your mic for just a moment. Okay, I'm going to switch. And we're going to get this so we can see the input just a little bit better. Bear with me for just a moment. I'm also going to put our questions that we posed to you just a little bit earlier up here. So let me fix this. And then what I'll do is I'll ask the questions, and then Hans, I'll let you unmute your mic, and you can respond to the answers. That way, for our recording purposes, we'll be able to the folks that are listening in will be able to hear those questions. So, all right. So it looks like we got to Tim's question. So I'm going to ask the question from Alex B, and then Hans and VJ, I'll give you an opportunity to answer. So does the sugar juice enter the fermenter? Differences from cellulosic ethanol in that there is no lignin or hemicellulose present in the fermenter? So I'll let you ask that question, technical question, answer that question.
Yes, we'll be glad to do so. So with tropical maize, we are still talking about first generation biofuels. It would be very similar to like squeezing sugarcane and getting the juice out and fermenting that juice, which is all sugars are fermentable in that juice. Same thing with tropical maize, is we are going to squeeze that maize out, get the juice, and then directly ferment that into ethanol. So it is not same thing as cellulosic ethanol where you're dealing with structural carbohydrates. This is all storage carbohydrates.
Okay, thank you for that. So Andrew's question, will you implement some sort of standardized methods, for example, NREL?
Sorry, I'm looking at, could you repeat that again?
Sure. So, on the great idea on politicals, the question is, will you implement some sort of standardized method, for example?
Oh, sure. Again, having the analytical, actually we'll have nearly a 3,000 square foot laboratory that will support the analytical side. So yes, we will be looking at standardized protocols, of course. I mean, some of the approaches and some of the potential areas that I think users will want to know about, include things like, what is the structure of the plant biomass, how much lignocellulose is present. Obviously, these things all impact ultimately the ability to process and ferment. And so that's why we feel that having the analytical capacity right on site, which includes all the appropriate types of equipment that you might expect in that type of a lab, I think was really critical.
Okay, thank you for that. So if you'll mute your mic for just one. Are you focused more on plant breeding and genetics instead of yeast pathways and plasmids?
Well, it turns out we're focused on everything. This is a really broad activity that we're envisioning in this facility. I mean, we see, again, plant breeders coming to us with re-engineered switchgrass or re-engineered whatever it happens to be, and then looking for its ability to be transformed into various types of bioproducts. So it really is, bringing together the plant breeders, the crop scientists, together with the folks that are doing the bioprocessing, having them talking back and forth, I think is truly a unique strategy. And we've actually had a small seed grant program over the last 3 years where we have encouraged faculty groups with those two different areas of expertise to work together. So we feel like we've already provided some foundational support for this type of activity. But really, the facility itself is really broadly designed to do all different kinds of things. And that's truly why it's such a unique facility.
Okay, thank you for that. So the next question is, what conversion technologies in addition to fermentation will be included in the facility? And you may have touched on that just a little bit.
So we are principally at this stage focused on what the Department of Energy refers to as the sugar platform. But that includes, as you might imagine, the various unit operations, which include pretreatment. And then also, because we have a very long history here in Illinois with corn processing, we have experts like Dr. Singh, who for years has worked in both the wet and the dry milling area of corn. But again, because others here on this campus, including myself, have been looking at next generation sorts of bioproducts, certainly that'll be part of what we anticipate to be the focus of the facility.
Okay, thank you for that. Where have you placed your students after they graduate? Specifically, which countries, or which countries do the students do they come from? How many stay in the U.S.?
Well, we have actually quite a good placement record. It turns out that the professional science master's program was actually a new venture, if you will, for the university 5 or 6 years ago when it was started. Our program was the first in bioenergy, and since that time we've placed close to 100% of the students. They go, interestingly enough, because it is a master's and more specifically a professional science master's, they seem to be able to take positions that that in many cases require multiple skill sets. Now, what I mean by that is that they get exposure to a broad area, and then they also get the business acumen that goes along with that. And we found that many companies actually value that. So it's kind of the difference between somebody doing a traditional master's that focuses on a very specific area, okay, versus somebody that has a broad understanding, but also comes to us with an undergrad, a strong science background, and then add to that the business side. So we find, our students are placed all over in many companies. Where they originate from at this point include places like Brazil. We have 4 or 5 students this year from Brazil, and it's kind of interesting. They bring with them a lot of interesting experiences which they are able to share with our domestic students here as well.
Okay, thank you for that. The next question is from Chris, and he asks, would you expect any IP issues if a small firm worked out of this facility to develop its product? We've got a small business question here.
So this is what we think is really especially unique about the IBRL. As the questioner undoubtedly knows, there are facilities around the country like this, but they are somewhat hampered in terms of allowing companies to go in and work at a reasonable cost. We actually designed this facility so that we can provide space and we can protect IP using those physical screens that I mentioned, and allow the work to be done and the interaction to occur to whatever extent that company or startup or whomever it happens to be, to whatever extent they wish to be engaged. Now, I assume that some companies will come in and really want to interact with our faculty. I mean, that's really a strength of this institution, is the faculty that we have. But there may be cases when individuals or small companies say, we just really need the space, we need access to the unique utilities, which I haven't specifically talked about, but which I can make available to those of you that are interested. And we'll leave you alone, essentially, to do your work. And I think you can feel at a very reasonable cost again, because we will be able to allow more than one company and more than one type of activity in that space because of the unique design.
Okay, thank you for that. So our next question, I believe tropical maize qualifies for, I'm sorry, can you mute your mic just a moment? Okay, so I believe tropical maize qualifies for advanced biofuel RINs, D5. So isn't that the same bucket as starch?
Okay, so good question, but we are not there yet. We haven't done this analysis, so really I can't comment about, what tropical maize would qualify as in terms of biofuel RINs.
Okay. So next question, could you please clarify when you think the construction will be complete and doors open?
Sure. We're looking, actually, it is scheduled for summer of 2016. They are a little bit ahead of schedule, I would say a couple of weeks. So we are looking either spring or summer of 2016 to open the doors of this facility.
Thank you for that. So a follow-up to looks like to Seth's question. He agrees about the tropical maize, and he wants to know a good deal more about tropical maize, not only for application here, but also for Brazil, Nicaragua, Mexico, and Caribbean. Any other comments on tropical maize, gentlemen?
Not really. We have only looked at, getting the juice out and trying to ferment it. Tropical maize can also be used for other uses, directly feeding it to the animals and for burning, for fuel, things like that. But no, we haven't looked at, how it could apply to, well, certainly for Brazil, we have looked in, where it can come in during the inter-harvest season, but we don't know about Nicaragua or Mexico or Caribbean yet.
Okay, thank you for that. All right, so next question. Does the IP automatically default to the university, or are you operating similar to the University of Minnesota's tech transfer, or even Penn State's tech transfer? Take a stab at that question.
Oh, so the answer is it depends. It depends very much on the type of situation. If it's a startup company that wants to essentially do all their own thing, then IP belongs to them. But uh, the the point that I'd like to make here is that the University of Illinois, over the 30 plus years that I've been a faculty member, certainly has developed what I think are user-friendly strategies for dealing with intellectual property. There's quite a bit of experience now over the years, and certainly they want to encourage economic development. And it's understood that if you want to encourage economic development, you have to work with with the individual companies in a way that deals with things like IP issues. So, without knowing any specifics about, the particular situation, it's a little bit difficult to answer the question. But again, it would very much depend on the situation.
Okay, thank you for that. Okay, so another follow-up question. So the building space is for rent to a company to use instead of using university resources?
I mean, exactly right. It would be a fee for use basis where a company can come in and use the space, and they would be charged on a fee per use basis. So yes, that in fact is so. If I didn't point out earlier, there is about when I described kind of the cross sectional view of the building, the high bay region is divided into two spaces. One which will be for faculty use principally, and that's a very open space, and the other half is essentially these individual spaces that can be walled off and can be rented to individual companies if that's in fact the need.
It looks like we've got a comment on tropical maize. I'll just let the audience take a look at that. I have a couple of questions for you myself. So the first is just from a small business perspective. We talked about IP a little bit, but say I'm a small business owner and I want to develop the technologies. What steps do I need to take to actually work out of your facility? unmic your
Oh, okay. John, could you repeat that again? Sorry.
Sure. So, small business owner, what steps do I need to take to participate?
Okay, so the first thing one would need to do is to contact us, and we will work with you on an individual basis. And as someone who had a startup company for about 7 years, I can tell you that if we had had a space like this, it really would have shortened our ability to get to the end game, if you will. So I would say we are developing protocols. We are developing um, um, the program, if you will. But at the end of the day, it's mostly about coming to us and telling us what your needs are. And because, again, this building is so flexible, we'll figure out a way to make it work for your particular situation. We'll also have, by the way, a pilot plant manager that will essentially oversee all the activities in the facility. And we'll also have a technician that will operate the analytical laboratory. And yeah, there will be an operational manual that will be provided as well again, depending upon the use that is envisioned for the facility.
Okay, thank you for that. So it looks like we are maybe wrapped up with our questions. I've got one other question for you, Hans. It's again related to the small business perspective. But okay, so I'm a small business. I'm working out of your facility. What other sorts of potential support or potential networking capabilities do you think you might be available, say, for me to try to find some seed capital to actually launch my startup, or if I've got my startup already going? If I want to apply for the SBIR program or something like that, what other sort of support related to funding my startup if I'm an entrepreneur and not necessarily directly associated with the university? Do you think what sort of resources do you think you might be able to provide?
If you're a small business, if you're a startup company, I would certainly encourage application through the SBIR process. And even more specifically, I would encourage building into the budget, um, you know, the if it's clear that the startup needs the space that we can provide and the support that we can provide, even building that into the budget for the SBIR would make a lot of sense. We beyond that, I would say that we can and would be able, again, based on my experience with a startup company that was eventually sold to a rather large chemical company, I can tell you that being able to get space of this type, high pressure steam, various types of utilities, and all that sort of thing that will allow startup company to carry out their unit operation of interest and scale it is a big deal. And we will be able to provide it at a level which I believe will be at a very cost competitive level. And of course, if you're a startup company, I mean, that's what it's all about. You want to be able to do things in a very cost-effective way.
Okay, thank you for that. I'm going to change screens real quick one last time. It looks like we had one other comment from Tom, and Hans and VJ, I'll provide a copy of this to you so you can have this for your own records. And with that, I think we'll go ahead and wrap up this presentation, unless I see any other questions pop up here. Hans, I want to say thank you to you and to VJ. I appreciate your willingness to participate in our webinar series. And for those of you that have questions about this particular presentation, I've got a couple of web links for email. So I've got Hans and VJ's email, and I've also got my email address up. So if you'd like a copy of this webinar, please feel free to email me, and I can provide that to you. Or if you've got specific questions for either of our presenters, please feel free to email them. And I do see that some of you are taking advantage of answering the poll questions, and I appreciate that. And with that, gentlemen, any parting thoughts? Any last comments?
I just wanted to say, we're really excited about this facility, and I think because of the broad functionality that this facility will have and the flexibility that this facility will have, I'm encouraged by those companies that we've already interacted with that have indicated an interest in using it. Again, it is a kind of a new model for us to have something like this right on the campus footprint. But I do believe it's a really great opportunity for our faculty to interact and collaborate more directly with industry. And I think that ultimately will have an important effect on the commercialization and business development here in Illinois as well as the Midwest region.
Okay, well, thank
you very much.
And thank you in the audience. We will end this webinar.
Okay, thank you.
Thank you all.
Thank you all.